Janine Ash. Thank you for joining us. Janine is and correct me if I'm wrong, if I recall, a biogeochemist with a fair amount of history in research in the field and now active with a company called Capture 6 that's doing things both in water recovery, carbon removal, and perhaps more than I know, both on land and at sea.
Great. Thank you so much for inviting me. I'm Janine, and I work with Capture 6. We are a carbon dioxide removal company that focuses on a myriad of hybrid solutions. And our core philosophy as a company is that carbon dioxide removal alone is not enough because, as we all know, climate change causes a myriad of problems. I was a researcher in academia for many years. And a big part of what drove me to actually working sort of at the front lines of these climate change solutions is I experienced personally many climate disasters that have been attributed to climate change. I lived in the Gulf Coast, and so historic floods, hurricanes, and freezes that knocked the power and the water out of my house, leaving me unable to leave because the Southeast has no infrastructure to deal with the ice that the roads were covered in. And those problems, we got through them, and they were minor for me, but there's a ton of these problems that communities are facing that they're much more dire at this point. And so I really wanted to spend my time and my skills addressing those. And so at Capture 6, we think that solutions have to be more than about just removing CO2 from the atmosphere. And so I'm going to tell you today about some of the different co-benefits that types of carbon removal can have in addition. And I think the previous speakers, Mike, Dick, and Nina, have done a great job of setting up a lot of the science. So I probably don't need to spend too much time talking about how carbon dioxide removal is really necessary. If you're looking at this diagram here, so the black line that moves into the red line, this is sort of where we've been with carbon dioxide emissions and where we're predicted to go based on the policies that have been implemented so far. And there's a big gap between that line and that black line down there at the bottom that says net zero. And so the blue and the green cones are sort of what we would need to compensate for in carbon dioxide removal to achieve that goal. I wish that we had done, our emissions reductions decades ago. I would be spending my time, on research boats looking at subsea floor methane, which was my passion and what brought me into the field. But we really need to basically execute these removals to limit the future impacts of climate change. And so how do we get from where we are to where we need to be? And of course, that's a really CO2 focused, temperature focused way of looking at it, lens, but it's important, I think, to realize that we're pushing planetary boundaries in many different directions. So planetary boundaries is sort of this, hypothesis that there's kind of been a safe operating space historically in terms of different conditions on the Earth. And that's kind of what's happening there in that green bubble in the middle, that green circle. And these are just the conditions that Earth has been experiencing over the last, several million years as ice sheets have advanced and retreated. To biology and freshwater and ocean acidification and different sorts of flows of nutrients like phosphorus and nitrogen. Anything outside of that green bubble, we're sort of in the zone of increasing risk all the way out to a high risk zone. So we already know that we're there with CO2 concentrations. We're getting there with changes to freshwater. And we're really close, perhaps, to pushing through over one of these thresholds when it comes to ocean acidification. For those of us live in the West, we know that climate change is water change. Drought area has increased by 17% when you compare drought area from 2000 to 2022 versus 1948 to 1999. And that's driven in large part by evaporative demand. So essentially warmer climates leading to higher rates of evaporation, driving these increases in the area that is impacted by drought. And coastal communities are especially vulnerable to drought. because a drought doesn't even have to be happening where you are in order for it to impact you, because you're dependent on those inland rivers bringing you water that's sustaining your agriculture, surface water that you're drinking in your house, and so on and so forth. And it has a myriad of other impacts, right? So if you are receiving less surface water, then your coastal basically geography is changing. You're more vulnerable to impacts from storms, as well as rising sea levels. So this is really a critical issue, sort of an axis of climate change in terms of how we're being affected by climate change. So I'm going to spend the rest of this talk thinking about whether or not we can build climate solutions that address these multiple axes of global change. And that could be everything from jobs to emissions reduction, water production, carbon removal, as well as the potential for ocean acidification remediation. And to do that, I'm going to tell you a little bit about the technology that Capture6 is building. So we focus on building integrated projects with multiple climate and community co-benefits, and we often do that with industrial partners who are either building from the ground up or in facilities that already exist. And the thing that we begin with in all of our projects is brine. All right, so brine could be salt water, but in our case, it's really closely tied often to wastewater brine. So brine that is a reject product from something like desalination or from water recycling or other forms of wastewater treatment. We take that brine and we put it through additional water treatment. And the first product that we create is more additional fresh water. The salt that remains, we use electrochemical techniques to basically split that salt water into two streams. One can be chemicals for industrial decarbonization. And then the other is sodium hydroxide, which then becomes the material that we use to absorb CO2 from the atmosphere using a process called direct air capture. And direct air capture is confusingly named because it is a form of atmospheric carbon dioxide removal, not the type of CCUS that you would normally associate with the word capture. And when the CO2 and the sodium hydroxide interact with each other, they form a fluid of sodium carbonate, which you may recall from Dick's talk is an alkaline fluid, which can be used for ocean alkalinity enhancement. So by putting this in the ocean, you can regionally raise the pH, as well as the aragonite saturation state, and draw down additional CO2, and the sodium carbonate will be converted into sodium bicarbonate, where it can be stored for up to 10 to the 5th years. The important part about this technology is that everything that's being used here in the stream is an industrial process that's already operating at scale. So Mike brought up the difficulty in building technologies like this. They're expensive, you have to build new supply chains, but everything that we use here is basically already working either as part of a water treatment facility or as part of basic air handling. So let's talk a little bit more about how this technology can kind of address some of these other, climate issues. So we are building a project right now in Southern California called Project Monarch. It's an integration with a water recycling facility in the Palmdale Water District, which is what's pictured here. So water recycling is really common in many other parts of the world that are experiencing water scarcity. It's essentially taking wastewater and retreating it and sending it back out as municipal sources of water. And in the United States, it has a bit of a stigma associated with it. And so Palmdale Water District is essentially running a pilot of this program. And they were going to produce a lot of brine as part of this pilot test. And so they were planning on using a traditional way of handling that brine, which is to put it in evaporation ponds, let it dry out, and then transport it to waste. And so as you can imagine, there are both emissions associated with that process, but also some big environmental impacts and human health impacts, because these evaporation ponds tend to create a lot of particulate matter, and sensitive populations like children, the elderly, anyone with a pre-existing respiratory condition, that really exacerbates those issues for them. And so we're able to take that brine by integrating into this project and use it to capture carbon dioxide. And we also improve the amount of water recovery that they're able to do through their water treatment process. So by the end, I think we produce about 30% more water than they would if they were doing this alone. And all of that water goes back to replenishing one of their local reservoirs where it's held until it's ready to be treated again and sent back out to homes. So this is one potential co-benefit that a carbon dioxide removal project could bring. And another one that's really important is emissions reductions, both through using these electrochemical methods that sort of split that salt water. We can create chemicals that would otherwise be used by industries made in carbon intensive ways, like often as a byproduct of a petrochemical process. And so instead, we're able to provide them those chemicals that have been produced just using electricity without heat under ambient conditions. And some of those partners are actually located on site with us. And so we're able to integrate with them, take their waste streams, as well as provide them some of these products to help them sort of lower their emissions. And then I think another one that's really important is stimulating renewable energy development. So these projects will take a lot of energy. And obviously, if it's running on renewable energy, that's the most beneficial thing. It would be the most carbon negative it could be. And if you're located in a small rural community, wishing that your energy source was cleaner, you might have a hard time attracting a large renewable developer because you don't have a huge off-taker. Whereas a carbon dioxide removal project could come in and basically stimulate a project like that getting built through investment and through sort of creating a long-term off-take contract for a resource like that. And this is an example of what we're doing at our project in Western Australia called Wallaby. So we're integrating with both an offshore CO2 storage project. We're taking the brine that's being generated from that, using it for carbon dioxide removal. We are providing green chemicals to an on-site green ammonia producer. And the entire project is also generating blue and green hydrogen. And we've attracted a solar photovoltaic company that's going to come in and essentially build out the whole energy source needed to run this project on renewables. And then I think there's also some significant economic opportunities that can come with these projects within the host communities. Because, you know, it's carbon dioxide removal is something that is going to be experienced globally, but the facility will be located within a community. And so what benefits directly is it bringing to your community economically, I think is an important one to ask. And so this is a study that was done by the Rhodium Group last year that shows the amount of jobs creation that can come first from building the facility. So that's the blue line that you see. And the dark blue is shows that the majority of jobs that are created are actually within that community. And then there's additional jobs created throughout the supply chain. And then once the facility is built, there will be additional jobs based on the operations and maintenance of that facility, which is, again, a larger number than jobs that are also created throughout the supply chain. And then finally, because we're really here to talk about the oceans, this idea about counteracting ocean acidification through alkalinity enhancement, as well as the ability to generate, you know, additional carbon dioxide removal, I think is still an important one that needs to be discussed. I agree with Nina, plenty of research to be done, really understand the impacts of this. But as it turns out, the western coast of the United States is a really efficient place to do something like ocean alkalinity enhancement. So this tool here is created by these 4 nonprofit organizations, Seaworthy, Carbon to Sea, Environmental Defense Fund, and Carbon Plan, which are great places to go to for resources to learn about all these different kind of techniques we're hearing about today. But what this tool is showing, each one of these tiles along the western coast of the United States is a different color. And the more yellow that color is, then the more efficient that water is at basically doing CO2 drawdown per unit of alkalinity that's added. So you can see basically here from, you know, Washington all the way up to Alaska, something in the range of about, you know, a 0.88 efficiency. So for every unit of alkalinity, you can draw down 0.88 units of CO2. And then, I think it's really important that, as a project developer, establishing trust in communities and throughout the industry. And the way that, we approach this, and many groups are working really hard on this, is showing you transparently and rigorously how we monitor, measure, report, and verify everything that we're doing. This is another acronym that gets thrown around, MRV. And on the western coast of the US, there are already amazing tools that exist. So the little movie that you're seeing here is from this model called Live Ocean, which was built by Parker McCready and his group at UW. And it's showing this aragonite saturation in the surface. So it's kind of this measure of how easy is it for a mineral to precipitate or not. With red being, very low conditions, dark blue being the highest conditions experienced here at the surface. And pretty much everything below 1.5 is something that's really dangerous for larvae who are trying to grow shells. And so using tools like this predictively and then post to measure what we're doing will be super critical as we move forward. So kind of to close off here, just as you think about the role of carbon dioxide removal and your community, I've done a deep dive on one, hybrid technology that I work really closely with, but there's, a wide range of solutions out there. And so knowing what's important in your community, because if the things I've been talking about, like jobs and water, are not important to your community, like that's okay, you're not alone. I think we have a representative from PNNL on the call, Jessica Cross, who's been doing great work on a grant along with other collaborators, interviewing communities, finding out what's important to them. And it's unique community to community. And so really having that conversation among yourselves and then with developers, I think will be key moving forward. And with that, I'll say thank you so much. And I'm really looking forward to our talk later today.
Thank you, Janine. Good talk, much appreciated. And I think this idea of a role in water recovery is particularly interesting for all the reasons you mentioned. There are even tribes in our region that are in the pincers of that problem.